Alright, and welcome back. Today we're going to do a little mini lesson on solving compound inequalities. I wrote out 3 little rules or some notes here to follow. The first one says follow the same rules for solving inequalities. Okay, so if you divide by a negative, you got to reverse the symbol. The variable that you're solving for should always be on the left hand side. Those type of things. For number 2, compound inequalities require you to solve more than one inequality per problem. So basically you're going to be solving 2 inequalities at the same time, not simultaneously, but at the same time. And number 3, always remember to graph these solutions on the same line. Okay, so let's go ahead and jump in and take a look at number 1. I'm going to rewrite it. So it says 6c minus 2 greater than 14, or 3c minus 3 less than or equal to negative 6. So we want to write these separately and solve them separately. Oops, wrong marker. 6c minus 2. Let me zoom in here. 6c minus 2 greater than 14. And we have to do 3c minus 3 less than negative 6. So for the first equation, I want to add 2 to both sides. Excuse me, for the first inequality, I want to add 2 to both sides. For the second inequality, I want to add 3 to both sides. And then I'm going to write the result of doing each step. So this one would result in 6c greater than 16, and for this problem over here we would have 3c is less than or equal to negative 3. Now for the first inequality, we're going to divide both sides by positive 6. And for the second inequality, we're going to divide both sides by positive 3. And the result over here is going to be c is greater than or equal to, well, let's reduce. Both of these can be divided by 2, which is going to give us 8/3. So c is greater than 8/3, or 8 over 3. And for the second inequality, c is less than or equal to negative 1. Neither one of these did we divide by a negative, so our symbols didn't have to be reversed. And the symbol was the variable that we were solving for was already on the left hand side. Now the only other thing we need to do here is graph both of these. And since one of our answers is a fraction and the denominator is in thirds, we're going to rewrite this one to say c is less than or equal to negative 3/3, because negative 3 divided by positive 3 is going to still be equal to negative 1. So when I write up my graph here, I want to definitely have more positives, because the 8/3 is a greater thirds than the negative 3. So this would be negative 3 over 3. This would be negative 6 over 3. Right. Oh, you know what? No. Let's just count them by thirds. So negative 1 over 3, negative 2 over 3, negative 3 over 3. Now on this side I would just have positive 1/3, positive 2/3, and 3/3, all the way to 8/3, 4/3, 5. Oops, this should be 6. And this is going to be 7/3. And this would be 8/3. And if we wanted to, we could put 9/3 right here. Now, just in case some of you all were wondering, if we really take a look at this, like negative 3/3 is really negative 1. This is still 0 right here in the middle. then this is positive 1, that's positive 2, and this would equal positive 3. 9/3 is positive 3, 6/3 is positive 2. So other than that, just going over that, now we can graph them. So we need an open circle on the positive 8/3, and we need a closed circle on the negative 3/3. And if we zoom in right here, for 8/3 we're going to shade to the right, and for negative 3/3 we're going to shade to the left. So when we go back to our graph, shade to the right over here, highlight and shade in the shade in the arrow, and go this way and shade in the arrow that way, and there's our graph for that compound inequality. Alright, let's take a look at number 2, and then we'll be done. Number 2, we're going to rewrite that as two separate inequalities. Now when we rewrite the first one, this is going to be 1 less than or equal to 4x minus 3. And then the second inequality we're going to write as 4x minus 3 is less than 9. Now let's go back to the first one we wrote, 1 less than 4x minus 3. We're gonna rewrite this one more time, because essentially we really want to write this part over here. That's how we really want to see it. So when we solve it, we're not confused, or nothing is our variable's still gonna be on the left hand side. So when we rewrite this, keep the 4x minus 3 in the same position, and we're gonna mirror what this says here. We're gonna mirror that. So if it was flipping over, if it was a reflection, it would be the mouth is still open towards the 4x, so the mouth has to stay open towards the 4x, and then the 1 would just go here. And now we can go ahead and solve these inequalities. So for this first one here, we would add 3 to both sides, and really for all of them we would add 3 to both sides for both of them. And now we're going to write the result. The result would be 4x is greater than or equal to 4 over here, and on the second inequality it would be 4x is less than 12. Both of these, the last step is going to be divide everything by 4, and that's going to give us x is greater than or equal to 1, and over here this is going to say x is less than positive 3. And now we just need to graph both of them on the same number line. So since both of them are positive, we can write the 0 over here, and the negative 1, then positive 1, positive 2, 3, 4, and put 5 here. Now the positive 1, if we zoom in here, we're going to have to shade that one to the right. And for the positive 3, we're going to have to shade to the left. So the positive 1 is going to get a closed circle, while the positive 3 gets a open circle. And the positive 1 I'm going to shade this way, right? And then the positive 3, really, oops, let me do that. Alright, let's get that zoomed out. So back to what I was saying, the positive 1 is going to go this way, the positive 3 is coming back this way. So the solution, this is how you would graph these two here. They're going to overlap, and we would just graph the overlap. The solution is between both of those numbers, including 1 but not including 3. Alright, and that is how you graph and solve compound inequalities.